introduce our first speaker, Jason DeTiberus. Hopefully I'm saying your last name correctly. He's a Kubernetes expert. Jason will be speaking to Cluster API with a bit of PXE Dust, bringing cloud-native declaration management of Kubernetes clusters to the data center. Take it away, Jason.
Hey, thanks. Let me go ahead and try to get my screen sharing going here. Yeah, we're going to talk a little bit today about automating the infrastructure management for Kubernetes clusters using a project called Tinkerbell. Who am I? My name is Jason DeTiberus. I currently work at Equinix Metal, helping to basically drive cloud native infrastructure management into the data center. I've been doing Kubernetes cluster lifecycle management for a few years now. I was one of the co-maintainers for the Cluster API project for quite a while, and now I'm also a contributor to the Tinkerbell project. To give a little bit of background on what Tinkerbell is, basically Tinkerbell is trying to take the best practices that we learned from building out the Equinix Metal cloud, formerly Packet. Some folks may be more familiar with that name, and try to bring it into a cloud native foundation project that anybody else can run. So bringing basically declarative API driven management to bare metal. And it does that through basically a few different microservices. The main one is the Tinkerbell workflow engine. It does all of the definition of your hardware. You get to define these things that we call templates, which are basically just like the step-by-step instructions that you want to run to provision that hardware. And then a workflow that basically just ties a piece of hardware together with a specific template and allows that hardware to instantiate it. There's also a boot service that provides PXE booting services, DHCP, and there's also a Hegel metadata service. That's an important bit. Similar to running in any cloud, it gives you the ability to query instance data from that instance itself, using it to being able to use things like Cloud Init to bootstrap instances, that sort of thing. There's also a worker component, and that's the bit that actually runs on the actual hardware and actually runs the steps in the workflow. The other component of what I'm going to run tonight is Cluster API, and it's a sub-project of the Kubernetes Cluster Lifecycle Special Interest Group. And similar to Tinkerbell, the idea is bringing declarative management to infrastructure, being able to define Kubernetes clusters using basically Kubernetes primitives. And it actually runs on Kubernetes itself, hence the stack turtle logo that we have on the slide deck here. Basically using Kubernetes to manage Kubernetes. And the way that Cluster API does that is you basically take a declarative cluster specification. If you're familiar with Kubernetes, it's basically all just YAML. So it's basically a big ball of YAML that defines what the cluster is. You throw that at Cluster API management cluster, which is basically just a Kubernetes cluster that's running these Cluster API components. And out the other end, you get a cluster somewhere in the infrastructure provider of your choice. And the project's built in a very composable way so that anybody can define their own infrastructure provider and plug in just the bit that they need to actually provision the infrastructure. And I know I breezed through that really quick, so I will be happy to answer any questions afterwards. But I wanted to be able to sit there and give a demo of what this actually looks like with actual physical hardware. In this case, I actually do have a small cluster sitting over here of hardware, and I'm going to attempt to provision a Kubernetes cluster using Tinkerbell and Cluster API here. So let's see if that'll actually work for me today. So what I've already done, I have this larger the boxes over here on the right. That's actually running Tinkerbell already. I've already bootstrapped the Tinkerbell environment. I also have a small Kubernetes environment that's running on my desktop, which is using the Kind project, which basically just runs Kubernetes in a local Docker container. And then I have these 5 basic small factor computers there on the left. And each of those are labeled A through E. And we'll see how that all works. I've already predefined the hardware, loaded that into Tinkerbell. And now I just need to do the cluster API bits. And I've already got cluster API installed on this Kind cluster here. So the next thing I need to do, and actually I can show you here, if I do a Tink hardware list, that's actually querying Tinkerbell. It shows that the hardware is already defined there, but I haven't actually told Cluster API about this hardware yet. So that's the next step that I have to do. And forgive me while I find in my notes the command to copy and paste this. All right, so I basically just defined some test hardware here. This matches the predefined hardware that I defined in there, and I just give the associated Tinkerbell hardware ID for each of these devices. And if I apply this to the Kubernetes cluster, and I get those hardware devices out the other side. If I do a describe on these, I see I get a lot more information back, and that's because now that I define that hardware for cluster API to use, it queries out to Tinkerbell and it gets all the information. So I can see in this case, the hardware that I have, each of them have one disk device. They're located at dev MMC block 0. All this was predefined. They all have IP addresses that are predefined, and they're all configured to UEFI PXE boot. Now that I've done that, what I can do is I can actually create the Kubernetes cluster. And I'm going to copy and paste this here. And what I'm going to do here is basically I define a environment variable here to override the pod CIDR. I need to do that because the default cluster template would try to configure the pod network with the default 192.168 network. And if I did that, it would conflict with the actual physical IP addresses that I have in the network here. So I'm overriding that. I'm using this cluster cuddle command, which is provided by the Cluster API project. It's actually what you use to bootstrap the Cluster API management clusters to be able to manage the Kubernetes infrastructure. And it also allows you to basically create what we call workload clusters from predefined templates. So in this case, I am using it to create the cluster from a template, which is this config cluster command. Naming the cluster demo. I'm telling it to use the templates from the actual local directory here, and telling it that I want one control plane machine, no worker machines to start with, and I'm specifying a Kubernetes version of 1.18.15. And that's important also because the way that we designed the Tinkerbell provider for Cluster API, it's all designed with immutable infrastructure in mind. So you use another Kubernetes subproject called Image Builder. It builds the pre-baked image for you. I've uploaded it already to this Tinkerbell machine, and it'll automatically pull it and use that pre-baked image. It's not trying to install anything on the fly. Everything will be built and verified prior to actually trying to use it. So let's go ahead and create that. And, oh, it did not create. And that was fun and short-lived. So I apologize for that.
Live demos, it's the risk.
Yeah. For some reason, the let me check. I can go back to this tilt screen. We can see if there was an error bringing things up. And yes, indeed, there was. And it looks like my system is not happy with me right now. So I apologize about that. What would have happened had things worked correctly is it would have gone ahead and created the resources because I don't have any type of automated lights out management on these machines. I would have had to look up exactly which of the predefined hardware devices that were defined would have been assigned to that initial control plane instance. I would have had to push the power button. It would have, created the templates and the workflow, populated with the with all the information needed. It would have set the cloud init user data on the hardware device, and things would have bootstrapped up nicely. But this is what I get for signing up last minute and trying to do a live demo that I didn't verify before. So I do apologize about that, folks.
Thanks, Jason. Unfortunately, the demo gods were not kind to us today to go through all that. Does anybody have any questions? Post them into the Zoom chat and I'll present them to Jason. I guess I have a question. So this is for doing provisioning bare metal for Kubernetes, correct?
Yes, exactly. The idea is behind the Cluster API project is mainly to just be able to do declarative management of Kubernetes across any infrastructure. The first, infrastructure providers that popped up obviously were like the big public cloud providers, Amazon, Google, Azure, that sort of thing. And generally, automating things like Kubernetes clusters around that type of infrastructure is generally easy. The way that most folks have approached provisioning Kubernetes clusters in a data center in the past has been something like, you pre-provision machines, give me a list of IP addresses, and I'll install Kubernetes for you. And you have a relatively static kind of long-lived cluster that ends up requiring a lot of care and feeding. With Tinkerbell, one of the things we were trying to do is take that public cloud type approach and be able to treat, the infrastructure in your data center more ephemerally. Using the immutable bootstrap images, we've optimized things so that when you actually run the Tinkerbell workflow, you don't actually have to reboot into the installed OS after we write the image to disk. We kexec into the kernel, so you don't have to take that additional time for an additional reboot for hardware, which in a data center could easily be 15 to 20 minutes for everything to post up. And upgrades are treated in a way where they're rolling upgrades. You're not upgrading these things in place where you have all of these different components in the stack that may not have been validated against each other in the exact same versions. The pre-baked images give us the ability to be able to build those validate those images using things like the conformance suites for Kubernetes upstream. You can do conformance testing to verify that Kubernetes and the base OS that you're using all play nice together and function as you would expect them to be. If you wanted to do validation against actual workflows that you have in your environment, you could do that so that you know that your workloads will work with the Kubernetes cluster and you're not going to be caught by any surprises with anything like that. And the rolling upgrades happen the exact same way. You're not trying to download the bits, at bootstrap time, so you don't have to worry about things like what if you have a flaky internet connection at that period of time and all of a sudden the machine doesn't come up the correct way, things like that. So hopefully that helps.
So let's see, first question. So it looks like there's support for x86-64. Is there support for other architectures like ARM or anything like that?
Within Tinkerbell, yes, today there is support for ARM. And we are looking at how do we enable that for Cluster API. The biggest challenges that we have there right now is basically getting the image builder stuff that we're using to work the same on ARM as x86. But that is one of the things that we're looking to try to address this year. And hopefully by the end of the year, we'll be able to actually provision ARM as well as x86 with this stack.
Cool. And then next question, is there a direct IPMI or Redfish support with Tinkerbell?
Yeah, so one of the things I didn't cover is there's another microservice component that we're still working on integrating with the upstream project, and we're calling it PB&J, and it does exactly that. It integrates with OpenBMC and Redfish to go ahead and enable those power type operations. And we're still trying to figure out exactly what that looks like. There's various ways that you can kind of compose the bits today. But if this is of interest to you and you have experience in this space and you have ideas, we are looking for folks to come and help us define what the right, kind of default architecture looks like for these things. The other thing that I'd like to add is that as we're building Tinkerbell, the idea that we're trying to bring isn't a monolithic stack to replace all of the infrastructure that you have in your data center for these types of things. We want to be able to integrate with existing projects. So we're working to try to define what the extension points for these things look like. If you already have things like CMDBs, how can we integrate with those and integrate the metadata service with those things so that you don't have multiple sources of truth for your data and that sort of thing. So it's still pretty early days in the project, but it's an exciting time. The idea is that you should be able to plug these components in into your environment in the ways that you need, rather than most of the projects in this space where it's like, if you want to use this, throw away everything that you have and drop in our stack in place of it, type of thing.
Very cool. If I could ask if you could drop a link to the Tinkerbell project in the Zoom chat, and for anybody that wants to contribute, how they can contribute to that.
Yep, absolutely. I'll drop the slide deck in there, and it has the resources with the links to all of the projects that I discussed today.
Awesome. So